Welcome back to my YouTube channel. Today, we are going to continue from where we stopped yesterday. Yesterday, I wrote out three trigonometric identities or three trigonometric integrals where we could adopt, or the integrals we can always adopt when we have something similar to integrate. All right, so without wasting much of your time, let's go into the video. So yesterday we wrote out three integrals. Today we are going to prove, we proved the first one. Today we're going to prove the second one. And if you have watched that video, you would see that the second one is the integral of square root of a square minus x squared dx. Okay. Yeah. Okay, so we want to prove that integral will give us, sorry, x squared x over 2 root a squared minus x squared plus a squared over 2 multiplied by sine inverse of x over a plus c. Solution. So yesterday we tried to look at this. We try to show the relationship between what we have in the bracket and we can use substitution method to solve this problem. So we already, if you don't get it, you need to visit the previous video. We already said that whenever I have this kind of function or expression, we should let x over a be equal to sine theta. Okay, so in essence, it means that you should say let x be equal to a sine theta. Please go to the previous video to grab what we are seeing here. All right, so we're going to differentiate this with respect to x. So say therefore, we'll differentiate x with respect to theta. We have dx d theta. And this will give us This will be a cos theta. Okay. So therefore, dx, or rather, this implies that dx is equal to a cos theta theta. Okay. So with that, we can say this, we can substitute this in the integral. We have the square root of a square minus bracket of a sine theta all squared. Okay, dx. So our dx is d theta, which is a, a cos theta d theta. Okay. So now we proceed. We say recall that 1 minus sine square theta. I did all this in a previous video, so I will not waste much time doing it here again. Is equal to cos square theta. Okay. So now I'm going to substitute this in the square root. So I'm going to have that the integral of a square. Let me use a curly bracket here. Use a curly bracket here. Okay, then we would have cover this square root of 1 minus sine square theta. Okay. Then a cos theta theta. I hope we are following. So now what we have in the bracket is cos square theta. So this will be integral if we take square root of a square, we'll have a. If we take square root of cos square, we will have cos theta. Then we have a cos theta. Theta. So what does this mean? It means we put a square, can throw the a square behind a times a square cos square cos theta times cos theta will have cos square theta. And we're going to introduce another trigonometric identity which says that cos square theta, another trig identity. Trig ID. So recall a trig ID which says cos square theta minus sine square theta is equal to cos 2 theta. Please recall there is another in a trigonometric identity that is this. All right, so now I'm going to come back here and swap the positions of this. So this can as well be 1 minus cos square theta. Okay, equal to sine square theta. Pari passu, superopa. All right, so I'm going to pick this. I'm going to pick this. I'll pick this. Pick this and then substitute. Then substitute it here. Rather here. No, here. I'm going to substitute here. So if I do that, I'm going to get that this implies that cos our aim is to make cos square theta subject to the formula. Because there is power here, it will be difficult for us to integrate this directly. But if we can introduce a variable, or if we can introduce the trigonometric identity or trigonometric function that has that is taking this format, to be easier for us to integrate. So we'll have cos theta minus, then I'll put bracket of 1 minus cos square theta. I hope we are following. Okay. Equal to then cos 2 theta. Cos 2 theta. All right, so minus times minus, minus times minus 1, means this will be plus. So we're going to have 2 cos theta, 2 cos square theta equal to, then minus 1 go to the other side, becomes plus 1. So we'll have cos square theta, sorry, cos 2 theta plus 1. Okay, so we can divide both sides by 2. So this cancel that. We now say this is equal to cos square theta. So right now we are going to substitute this. We're going to substitute this into this. Substitute that into here. Okay. So if we do that, we now have that this therefore means that this integral is equal to this. So the integral root a squared minus x squared dx is equal to a squared over 2. So this is over 2. Then we'll say integral of cos 2 theta plus 1 theta. Right now, we can now integrate. We can integrate following. Right, so we integrate. So now we integrate that. We're gonna have a square over 2. Then if we integrate cos 2 theta, we have sine sine 2 theta over 2 plus theta. Okay. So what does it mean? Plus C anyway. Plus C. So now this is sine 2 theta. We can, from the trig identity, which says sine 2 theta is equal to 2 cos theta sine theta. Is another trig identity. And then we also have that this can be 2 cos theta. Cos theta square root of 1 minus sine square theta. Okay. What we're following. I hope we are following. Then from here, our sine theta is equal to x over a. So I'll plug it in here. And square root of 1 minus x squared over a squared. So this will be square root of let's not mix it up. This will be square root of a squared a squared minus x squared. So this will be square root of a squared minus x squared over a. So this is cos theta. So we'll fall back here. So we'll have 2 square roots of x squared minus x squared over a. Okay. Then what is sine theta? Sine theta is x over a. x over a. So at the end of the day, this will be 2x over a squared. Square root of a squared minus x squared. Hope we're following. All right, so I'm now going to substitute this into this. Okay. I'm going to substitute this into this. But if I do that, I can open the bracket with this that I have outside. So I'll have a squared over 4. A squared over 4. Then this will come in as 2x over a squared. Then square root a squared minus x squared. Okay. Then plus a squared over 2. And from here, we can say, from here, we can have that theta is sine inverse of x over a. So we'll plug that in here. Sine inverse x over a. Plus c. Now we can cancel this. Cancel this with this. 2 cancel here. Cancel here too. So at the end of the day, I have x over 2 root a squared minus x squared plus a over 2 sine inverse x over a. See. All right, thank you for joining me. We have just proven this. So if you have any question in the comment section, please put down your question. I'll be glad to answer you. Please do give this video a thumbs up and then like, subscribe. Thank you for joining me. See you in the next video. Bye-bye.